So let's see for question 5. A polynomial. So our polynomial given here, there are missing value. Mn didn't give here. So this polynomial, when it say can divide exactly means it have no remainder. The polynomial will equal to 0 when it divide by this divisor. So this divisor we can factorize and find out what is our x value. So can divide exactly means this also is our factor. Then find using this information, our first task, find Mn. Then use this Mn continue to factorize completely and solve. Solve means find out what is our x value for this polynomial power to 4 using the px. So we go for the first task. When they say divide exactly by this, so our divisor here is x squared minus 2x minus 3. So we factorize it so that I want to find out what is our x value actually. So this one factorized will be x plus 1, x minus 3. So means that we can use our theorem, factor theorem, because we don't have any remainder. If we got balance or we have remainder, it will be remainder theorem. But they said this one, it can divide exactly means it is a factor theorem. So for the x equals to negative 1 come from this factor. So it can divide exactly. Therefore, our polynomial here will write as p, substitute the x equals to negative 1 and let it to be 0. Continue. Another information, it will be when x equals to 3, substitute 3 into the polynomial also will equal to 0. So that is the keyword they give us because they said can divide exactly. Means you don't have any remainder, it will equal to 0. If remainder theorem means it got numbers, what's the numbers they're leaving after they're doing the division. So from here, we find these two unknown. So we have two unknown, we have two information. Substitute the negative 1 inside our polynomial here. Negative n here will be equals to negative 8, then minus n plus 6 equals to 0. So from here, negative n will equals to 6. That will be our first equation. So we use continue to second information here. We substitute 3 into our polynomial, 27m minus 72 plus 3n plus 6 equals to 0. So we simplify our equation. Here we'll get this will be our second information. So we solve the simultaneous equation here. You can see we have similar n. One is negative, one is positive. So we will take equation 1 plus equation 2 so that our n will be eliminated. So when you plus it together, the m here, it will leave equals to 8m equals to 24. So our m, we found it, we get 3. Then we substitute into either one equation. I choose equation 1 because this is like smaller value, easier to calculate. So we can get n equals to negative 5. Is it? Oh yes, here we got a mistake. This one we got a mistake, it's not 6. 2. So here will be 2. So 5. Negative 5. Okay, so what is important at here? Our theorem, our factor theorem. Write the theorem correctly. What value should be substitute and then equals to 0. This is factor theorem, 1 marks. This is also factor theorems, 1 marks. So basic concept. Then substitute, concept of substitute working. Find out our n and n. So jot down your marks. So we continue. They say use this m and n value. So means our polynomial here will be incomplete. This one will be equal to 3x squared. So this one will be negative 5x. We have to factorize it completely. So when we say we have to factorize it completely, we have to find out what is their factor. So one of the factor is this quadratic. And this quadratic can be factor. We can find here got 2 linear factor. So normally cubic you will have 3 linear factor. Like quadratic have 2 factors. Like quadratic is x power 2, so it has 2 factor. So if cubic, right, so it is x power 3. Normally you will have 3 linear factors. So I have to find out what is another linear factor. What is the factor here? So what can we do is, we take our polynomial, we divide these 2 factors, we will get another factors. Okay, so we will do the long division. Take our polynomial m, which is 3x squared, then negative 8x squared, then minus 5x plus 6. Divide with our factor. Our factor, we got 2 factors, so we divide these 2 factors together. Take the expanded form here and divide by these 2 factors. When we divide these 2 factors, what we get here will be another factor, so we can factorize it completely. So how to do this long division? We will find the multiplier, which can cancel this 3x squared. So you can 3x cubed. So what's the value we need here? We can divide back. 3 divided by 1, so I need a multiplier of 3, so that when I 3 times back 1, I get 3. So you can see x cubed divided by x squared, I need a multiplier of x. Then we multiply back. So when I multiply back, I will get 3x cubed. So I managed to divide this term, to finish out this term. So the rest of it is just expand. 3 with negative 2, we get negative 6. X with x, we get x squared. Then 3 with negative 3, we get negative 9. Then x, then we see what is our balance. So every time after we long division, we must able to finish the division at the first term here. So you can see our first term 3 minus 3, it is equal to 0. So we success to do our division here. We continue to the following terms. Negative 8 minus negative 6. So negative become positive. So here also negative become positive 9. So it become positive x. Then here is 0. 6 minus 0 remains 6. Then we continue. We will still continue because this is quadratic. They also can quadratic. They can divide. They can proceed to divide. Unless we get a polynomial which is smaller than divisor. What's mean by smaller than divisor? Our polynomial will be follow the ranking. The smallest ranking is constant. Then continue with the linear ax plus b. Then continue with quadratic ax squared bx plus c. Then continue with x cubed. So the highest power, the more higher power, the more higher ranking. So when we doing our division, we must make sure what we get here balance is smaller from this. So they are same now. They are same ranking, quadratic and quadratic. So the division still can go on. So what's the multiplier numbers we need? Negative 2 with 1 divide, we have to times with negative 2. Then x squared no need because already have. So expand that. Expand this. And then expand the following term plus 4x, then plus 6. So we can divide exactly. So you'll notice that when we divide it with a factor, we don't have any remainder left here. So our polynomial, we can write like this. Polynomial equals to the factor x squared minus 2x. Our divisor is this. Our quotient is 3x minus 2. And then just now, our divisor, from the quadratic part, we can do in terms of linear factorize. So we managed to factorize it completely like this. So a cubic polynomial, it will have 3 factors together. So the long division, concept of long division to finding another remainder, and then we get the quotient and the answer here. So our answer, of course, will be this part factorized completely. Means from the quadratic also we need to factorize it, become one by one. So one factor, another factor. So we have 3 factors here. We continue for the third part of the task here. After we factorize completely, hence we need to solve this polynomial power of 4 by using this polynomial px. So means this polynomial power of 4 and this px, they've got relationship. So we try to take this polynomial, divide by this px and see what we get. So the given polynomial here is x power of 4, which is 3x power of 4 minus 14x cubed, then plus 11x squared, then plus 16x minus 12. So every time you do your long division, make sure your terms here is arranged in order from the higher power to the lowest power here. So power 4, 3, 2, 1 constant. So the divisor, we use our polynomial px because they want to solve this polynomial power of 4 using px. So this is our px. Okay, so what we need to do the long division here, we need an x here. We only need an x here. When we expand, we automatically will get 3x4. So our first term will be solved. Our second term will be complete. Then continue expand for the other term. And we minus to see the balance. So negative 14 minus negative, so it may become positive 8. Here minus become positive 5, so it becomes 16 together. Then minus 6 here will become 10. Then 12. So we still can continue. You can see x cubed, we still can continue this division. We need from the 3, what multiplier we multiply in so that I can get negative 6. So we divide negative 6, divide by 3 means I need a negative 2. So again, we multiply negative 2 with 3, negative 6x cubed. So we've done our first term division. Continue for the rest, negative 2 with negative 8, positive 16 square, x squared, then positive 10x, then negative 12. So we managed to divide it completely. We don't have any remainder. So from here we can see 3x4 minus 14x cubed. When it equals to 0, they said ask us to solve when it equals to 0. Actually, this part is equals to the quotient, which is our polynomial, times the quotient x minus 2. So we can put in our polynomial factorizers now. Our px is equal to x. In the factor form, we take the factor form here so that we can solve it equals to 0. So when I want to solve it, means I want to find out what is our x. X equals to negative 1. Then x equals to 3. This is x equals to 2 over 3. And then this is x equals to 2. Alright, so you can see this polynomial power of 4, it is our px times with our x minus 2. So both of them are the factors of this polynomial power of 4. So from the factor, we only can find the roots. So from here, using our polynomial px here, we divide and then we do the long division to find out our factor. Then use the factor form from our px to find out our roots, which is x equals to something. That is we call roots.